Okay, many times people have asked me about Kolbe electrolysis. So this is a basically method for preparation of alkane, Kolbe electrolysis. Now you see, this is a method of preparation for alkane. Now why not? Many times I have discussed in the class, because I have not found this reaction in any foreign author book. But they discuss in the Indian author book. Maybe I am not able to find the book. It explain. So let us say what is this Kolbe electrolysis. So I can say this is a method of preparation of alkane. First thing, so this reaction is used to prepare alkane. So this reaction is used to prepare alkane. Now general reaction I can write 2R COO minus Na plus, and with water 2H2O. If I do electrolysis, I should able to get RR plus 2 molecule of CO2 plus 2 molecule of NaOH plus H2. So this is the general reaction. This occurs at anode. So NaOH plus H2 at anode, and RR plus CO2. So RR plus CO2 up to here, not this part. So this occurs at cathode. So you see, important point is at anode NaOH and H2, at cathode that is RR and CO2. You see, as reactions goes on, solution will have more NaOH. So solution will become basic and basic and basic. So as time progresses, solution will become highly basic. So I can say electrolyte becomes basic as time goes on. This means I can also say pH increases with time. So if time increases, pH increases. Now if I see the mechanism for this reaction, now reaction mechanism is easy one. So let us discuss mechanism. So what happens? We have a RCOO minus. So we have 6 electron. Now we can lose 1 electron, and I will get RCOO and O dot plus 1 electron. So this is a basically oxidation, and we know oxidation occurs at anode. So this is oxidation that is occurring at anode. Now similarly I can further, so radical is found in the first case. Now in the next case, now there are 2 electron here. I need, if I push this electron here, if I push this electron here and push this electron here, I will have R dot plus CO2. So CO2, you can see Lewis dot structure will look something like this. So you will have a CO2, R dot plus CO2. Now this R dot in the next step can combine with another R dot, because in reaction mixture there are many R dot that is produced using this step. So R dot can combine. So basically this is a radical coupling reaction. So this step is nothing but radical coupling. So if radical couples, you will get this. Now in the next step, so you see, you can generate a alkane. Now this alkane will be symmetrical alkane. So in this case you are getting a symmetrical alkane, RR. Now what will happen at, so this is happening at anode. So now you can see this whole process is occurring in anodic chamber. So this is inside the anodic chamber, anodic compartment, or you can say anodic chamber. Now so these reactions are happening in anodic chamber or anodic compartment. Now what is happening at cathodic compartment, you can say. So now this Na plus, because reaction vessel there is a Na plus also. Now this Na plus, so see there is a Na plus, for per RCO minus there is one Na plus. This Na plus takes one electron and it forms Na, so this is a reduction reaction. Now reduction happen at cathode, so this is a cathodic compartment, so this is cathode. Now Na is so reactive, as soon as it is formed it reacts with water and it forms NaOH plus H2, everybody knows, and H2 gas can be released out. So you see these two reactions happening in cathodic chamber, or you can say at cathodic compartment. So this is happening at cathodic chamber. Now you see, so this reaction is happening in cathodic chamber or cathodic compartment. Now you see, so important point, if you have this reaction you can prepare alkane, but only you can prepare a symmetrical alkane if you have something like this, RCOO minus Na plus, RCOO minus Na plus. If you do electrolysis, now in this case you will generate a radical here. So let us put one CH2 group here and one more CH2 group here. So RCOO minus CH2. So now you see what is happening in the step. You are generating a radical RCH2 dot. So this radical will generate, but these radical will further combine and you can generate an alkene. So you see, you can even generate an alkene using this kind of reaction. You can may close the ring. So you see, if you have something like this, so RCO, so if we have, let us make a more membered ring. So if we have RCOO minus and O minus, if you do electrolysis, now intramolecular reaction is always faster than intermolecular reaction. So you will have something like, you will get a radical here and you will get a radical here, and now you can combine these two radical, you will get a 1, 2, 3, 4 membered ring. So you will getting a cycloalkane. So this reaction can also be used to prepare cycloalkane. So this is also important part, because you can get a intramolecular reaction. Now Kolbe electrolysis is used to prepare. What will happen if somebody asks, if you are doing electrolysis RCOO minus plus R-COO minus, so you have a mixture of RCOO minus and RCOO minus when you are doing electrolysis. Now in this case you will get R dot, you will get R dash dot. Now you will get 4 product. The 2 separately can combine. Okay, you will get the 3 product. R dot R can combine, R dot R dash dot combine, R dash dot can combine. So you will get RR. So this is not a RS configuration. R dash, or you will get R dash. So there are 3 possible alkane in this case that is possible. So 3 possible alkane. So you can say this is a cross so 3 possible alkane. So this is a cross Kolbe reaction. So this you can say this is a cross Kolbe. There is nothing like cross Kolbe in the text. It is not, literature you will not find a cross Kolbe term, but you can think it's like cross Kolbe reaction. Now if you think this reaction, this is an intramolecular Kolbe reaction, you can call it, this is an intramolecular Kolbe. So this is a intramolecular Kolbe reaction. So simple. So intramolecular Kolbe reaction. So this is all about the Kolbe reaction. This is a preparation method of preparation for alkane. Generally we does not discuss this in the class. Okay, thanks.